Hello, hey guys, welcome to Concept and Coding and Happy New Year first of all. And today question is very important, Splitwise Simplify algorithm, right? But before that, if you have not seen, this is the channel Concept and Coding and this is the playlist low level design from basics to advanced. So in this, the latest one, 21st video, low level design of Splitwise. So this is the first part, you can say, where we have covered how to design a splitwise, right? It's UML, coding and all low level design. The second part of this question is the low level design splitwise simplify part, right? So you already aware that, okay, let me tell you what is simplify from start, but at least that is the first part. If you haven't watched that first part, I would highly recommend that go first watch that one and then continue with this one. Okay, so now let's start with the splitwise simplify algorithm and let's see what it is. And to be honest, this has been recently asked in a very top product based company, right? I won't take a name, like I generally refrain from taking any names, but it's been recently asked. So this is very important from DSA perspective and from LLD perspective, both. Okay, so now let's understand what is splitwise simplify, right? How does it works and what is its algorithm? So consider this. What is a splitwise app? So now you have already watched the part 1, you know what is splitwise expand sharing app. So let's say there are 3 persons who are living in an apartment A, B and C, right? So now let's say it is like from to amount. Let's say this is the function which or the array which we will get. So A, B, C. Let's say A has to give 5 rupees to B, right? So what it would be from A, 2 is B, amount is 5, right? Comma. Let's say B has to give again 5 rupees to C. How it will be represented? B from B to C. B has to give to C how much rupees? Amount is again 5 rupees, right? And let's say C will has to pay 10 rupees to A. So means from C to A, how many rupees? 10, right? And let's say A has to give 1 rupee to C. So what is A has to give to C? How much? 1 rupees. So let's say these are the number of transactions which we have come up during our splitwise. How many transactions? 1, 2, 3, 4. So the main purpose of simplify, splitwise simplify, is to reduce the number of transactions. Reduce the number of transactions. The amount which each member owes will remain the same. For example, let's say this A owes 200 rupees. Let's say, I'm just saying an example, right? B owes 500 rupees. So let's say even we do simplify, even our target is to reduce the number of transactions. Let's say from 4 to 2 or 3, anything, or even 1. The amount they owe will remain the same, right? That will, the amount they receive, the amount they will give, that will not change. That's what I mean to say, right? So only the main purpose is reducing the number of transactions in the system. Okay, now let's, so you got it right. Now let's take this graph again and see how we can simplify it. Let's first visually and then we will see, I will tell you how we can splitwise doing it. So A, B, C, and then we'll quickly, this is what we have drawn, 5, 5, 10, 1. So let's say A has to give to B, B has to give to C. So we can, so I am just saying from our normal, without algorithm, without any logic, I am just saying from a human perspective, like how we think of this thing, how we can reduce. So we see that A has to give to B and B has to give to C. Why not A directly give it to C? So we will say that, hey A, you give directly to C 5 rupees instead of involving B, because B is getting and B is then paying, right? Then what we will see, so this is our first version, right? And C again has to give 10, A has to give 1. Now what we will see, hey A, so the transaction is only between A and C, and A is getting 10 and giving 5 and 1, 6, right? So we can be like, A is getting 10 rupees, A is getting from C, and 6 rupees it is giving to C, means it is getting only 4 rupees, right? So this 4 transaction has been reduced to only 1 transaction, right? But this is our way of looking. But how we will compute it algorithmically, or how Splitwise has done it? So now I'll tell you how it has been done in Splitwise, right? And this is very, very important. So let's say this was our graph. Okay, so this is 5, 5, 10, 1. So what Splitwise done is, it compute the in minus out, or what I will say, that incoming minus outgoing, incoming minus outgoing for each of the transaction. So let's say, what is the incoming and outgoing for A? Incoming is 10 minus outgoing is 5, outgoing is 1. So what is the balance? 4, right? Positive means incoming is higher, right? Means it has to get the money, right? So 4 he wants. What is the incoming minus outgoing for B? 5 is incoming, 5 is outgoing, that's all. So it is 0, right? So how much, whatever B is getting, the same amount it is giving also. What is the in and out for C? It is receiving 5 rupees, it is receiving 1 rupees, right? So total incoming is 5 plus 1, 6, and outgoing is 10, right? So it is minus 4, means it has to give. Negative is right. So incoming minus outgoing, when outgoing is more, then only it will be negative. So means this is outgoing, it has to give, negative means has to give, positive means it will receive this much money. Now if you look at the system properly, here if you see, right, what is let me draw this A, B, C. What we computed here in this, A is 4, right? Incoming minus outgoing, A is 4, B is 0, C is minus 4. So one thing you notice, right? First thing you notice is the amount, the sum of all these values, right? 4 plus 0 minus 4 will be 0, right? Because we are not changing the amount they owe, amount they have to give, right? We are just simplifying the number of transactions. So that's why when we do incoming minus outgoing, right, and whatever the everyone owes, right, it would be in the system, because system is not creating any new money or deleting any new money, right? So it should be 0. Second thing is, another thing notice is, those who are already settled 0, means they are not contributing much, means they are not required. Why? Because see, 4 is positive, means this is the receiver, it has to get the money. Minus 4 is means it is the giver, it has to give the money, right? So we have a receiver, we have a giver, but those who are 0, they are not even required, right? So zeros, members with 0, or I would say incoming minus outgoing, which is, I would say, let's say call balance, with 0 balance, right, are not required, right? We will not require those who are already 0, we will not require them in helping in reducing the number of transactions, right? So you got this one. Now if let's say we have a complex graph, like say I'm just taking an example now. Let's say we have so many, right? I'm just taking any random graph, like let's say it's not, I'm just taking randomly. Let's say anybody has to pay anybody, like let's say it's a huge group and each is paying anyone, right? But ultimately their incoming minus outgoing, right? Incoming minus outgoing is, let's say it is minus 200, means it has to give. Minus is minus means outgoing is higher, it has to give 200 rupees. Let's say it is 70, means it has to receive. It is minus 40, it has to give. Let's say it is minus 100, right? Let's say it is 0, that is minus 30, this is 300, right? So let's say this in this system, these are the incomings and outgoings, or these are the balances for each one, how much they have to give, how much they have to receive, and 0 is means he will not be even required while doing a simplify, right? Now if you see that we don't even have to remember this graphs if we know this value, right? Which value? If we know this, who are the receiver, who are the givers, we don't even have to worry about this one, graphs, right? We don't have to worry about this. Now it become little bit simplified, right? So we know two things. What two things? We know who is the receivers and who are the givers. Receivers means those who are in positive. So positive is 70 and 300. Givers means outgoing is more, right? So 200 is negative. So these are givers. Minus 40, minus 100, minus 30, and zeros are not even contributed. So now if you see that the sum of all should be 0. So because the money receiver want has to be fulfilled from the giver only. System should not generate any new money, right? So now we have these two things. Now let's create one array. So now let's say 70, 200, 300, minus 40, minus 100, minus 30. So this is my balance list. Now this is my balance list, right? Which has receivers are positive ones and givers are negative ones, right? Now one more notice, right? What Splitwise does is they know that if one person gives money to many people, then it is also possible that the number of transaction will increase. So initially let's say it has 10 transaction, right? Let's say 5 transactions initially, and we wanted to simplify, and we have this receiver giver, and let's say if we say that one person can give money, a receiver can get money from lot of persons. So means giver is giving money, let's say it is giving 10 rupees to this one, so it becomes 60, it become minus 190. It giving, let's say 10 rupees to this one, it become 290, it become minus 180. How many transactions till now? 2. Now let's say it is saying that I am giving 10 rupees to this one, for example, right? So it become 40, it become 30. So now what I wanted to point out, if we go that okay, they can give partially, if they can give partial amounts, then the number of transactions can be even more than what originally it was, right? So what Splitwise tells that always give the full amount. You can always give to one member the full amount. Let's say he is the giver and they are the receiver. So 200 can, let's say, wanted to give full amount to this one. So it will become 0 full amount. And let's say if it is giving to 70, then how much it will become? It will become minus 130. Right? That's what it will be, right? So 200 has been paid to it. So 70 rupees is fulfilled and then it has to be, it become a new giver kind of thing, right? So then it has to pay. Then 100 rupees will become 0. It is giving full money to, let's say, this one, so it will become, let's say, 200, right? And let's say this is become negative, so let's say this is giving full money to this will become 70. Then this will giving full money to this one, this will become 30. This is giving full amount, this will become 0. So all become 0. So one thing we notice that what I told you, that let's not give partial amount. If any giver is giving the money, the giver will become 0. The giver will become 0, and whichever to whom it will give, that balance will change, right? So this has, now it's kind of a, now let's say, balance list. Now let's understand this. Now this become a DFS problem, right? So now let's say this is the balance list: 70, 300, 40, 100, minus 30, minus 200, right? Now let's say what will happen, I will iterate from here. Okay, so here I am saying that, okay, I got 200, so I got one receiver, this is the receiver and this is the giver. So I got one matching of receiver giver, positive negative, right? Whenever there is a positive negative means transaction can happen. So what it will become is, let's say this will become 0 and this will become your the new updated amount. So it will be become 70 rupees get fulfilled, it will become minus 130. 300 minus 40 minus 100 minus 30, right? So this is one use case. What is the another use case? What if, so this is just a DFS. So currently 70 is the receiver, this is the giver. So this giver has give the money. What if 70 is got paid by this minus 40, right? So here what will happen is, this will become 0, minus 200, 300, and this will become a new value 70, 40, right? So it will become 30, right? This is the new value. That's what I am trying to say, that because we have to create a new array, that every time any transaction happen, one should become 0. That's what I told you. Any time any transaction happen, one will become 0 and another will just get updated. So here currently I am at this. So let's say I found, okay, minus 40 and positive, minus and positive interacted means transaction can happen. So I make this 0 and I updated the next one is like 70 and minus 40 is 30. This become 30 because it has to give only 40, but it has given 70. So means 30 it has to receive from someone, right? You got it, right? So it's a normal DFS, like who can pay to whom, negative, positive. So what are the other combinations it can have is similarly. So now let's say in this graph, I'm just going more deeper. So now what is negative and this is positive? This again, yes, transaction can happen. So let's say my index is here. So wherever my index is, I will make that 0, right? And the other one, the other index my here is, I will update that one. So 170 is the new amount, correct? And this has become minus 40, minus 100, minus 30. Similarly also possible is, also what is the possible is 130 is is not giving to 300. It might be, can it give to anybody else? 40 minus 130, no. So it will pay to this one only, right? So any other combination is not there, not possible here. So here it can be further drilled down to 170. My index is here, and my another index would be there, because I need to try all the combinations, right? So let's go here. So you got it, right? What? So this is a regression, and we will count the number of transactions. Wherever the transaction count is less, we will pick that one. So it's a DFS, and I will tell you this is NP hard problem. This is the NP hard problem. And now let me tell you the code of this. So what is the input? Input would be like your 2D array like this. This is input. Now let's say here in this case 0 1 2. Just assume ABC is 0 1 2, right? So now let's do the coding for this one, right? So this is my array. Okay, so now what side is, what I'm currently trying to do is compute the overall balance, incoming minus outgoing for each member, right? So here what I am doing is iterating over the transactions. So what my transaction has from, to, and amount, right? So int, my from is transaction 0, int 2, transaction 1. This is my from, to, and amount, transaction 2, right? And I just need to do incoming minus outgoing for each one. So I just have to update. I need to take one hash map, right? I need to take one hash map, integer comma integer, member, I'm taking member versus balance map equals to new hash map. Okay, so I got a hash map. I am trying to compute a balance. So member versus balance map dot put. So from, I need to first update from, let's say, so he has, so from has to give the money, so amount has to be reduced, right? It has to give. So from, so incoming minus outgoing, right? So incoming it hasn't got any, but outgoing is going. So incoming minus outgoing. So from, I need to do, so first of all, whatever the balance is present in the from, get or default from, if nothing is present, I would say that 0 is the default value, minus amount, because incoming we are doing minus outgoing. Similarly, I need to update the 2. 2 is receiving the money, so it will be plus, incoming minus outgoing, so incoming is plus. Now I got the balance for each one. Once I got the balance, I will just put into a balance list, right? So I am maintaining a list of integer, right, balances, new array list, right? So this is something, I created the balance list and I am just take the balance. So int amount get, so here I will take out its values, right? And I told you, right, if amount is equals to 0, then they are not even contributing it, so we won't want to add. So if not equals to 0, then only I need to add into the balances dot add amount, right? And now let's try to do DFS. Here search, I have a balances list and let's start from 0. Now let's write our DFS code, right? So it's like DFS list of integer and then called current index. I am currently at this index. So I told you, right, now I have a list of array balances, this array, I got this. So current my index is this, right? Now what's my next is, I have to find out a next negative number so that transaction can happen. So my base condition is if my so here this is the balances list, balance list. If balance list dot size equals to 0, or my current index become at the end balance list dot size. In both the cases return 0. Or if I told you, right, zero values do not even contribute, so this is a safe list, that if balance list dot get current index, if it is 0, it won't be, because we are adding only not equals to 0. It's just a safety check. If it is still equals to 0, we will again say that I think it will not be there, we are already skipping it, so let's it's an unnecessary duplicate check, so we can remove it. But if you want it, like we can still have it, because it's always good to have our edge cases independent, so right. So let's say even if it is 0, what we have to do, we have to just increment the current index, because we have to skip it, right. So I will return DFS my balance list. I just have to increment my current index +1. Okay, now let's move it. What is my current value as of now? Current value is my this. Now let's say, and I have to find out the minimum transaction count, right? Minimum transaction count. So minimum transaction count right now currently say that it is maximum integer dot max value. I have to find the minimum, right? So now let's say what I am trying to do is I am iterating the for loop, and here I told you, right, my one index is there, current index, and here another I am iterating internally to find out any negative numbers, which, or any opposite number, positive, negative. If my current index is at negative, I need to find some positive number, right? So it is my you can say that I'm just taking transaction index, where transaction can happen. It will always be +1 from what my current is. So my current index +1, it will always start from there, right? And transaction index, it will iterate through less than balance list dot size transaction index plus, right? Till now I hope all clear, right? So now let's dig more deeper into that one. Okay, so what is my next value, whatever the transaction is? So my next value is balance list dot get transaction index. So when transaction can happen, when a positive negative interact. So if current value into next value is less than 0, means one is positive and one is negative, then only a transaction can happen in between them, right? And I told you that whenever a transaction can happen, wherever I am current, I am making it 0, because I already told you why we are making it 0, because we don't have to do partial payments, which is like one becomes 0, other will become either a giver or a receiver, right? Or become the same, whatever in the category it is. So my balance list, I have to update the next one, not the current index will automatically +1 will happen, so it will automatically get skipped. So I just need to set the transaction index with current 12 plus whatever is the next 12, right? So it changes, so that next value become changes, not the current one. Current value we will do +1, so automatically it will be skipped. So we are updating our array now, kind of, and we have to find the minimum transaction count, right? So now transaction happens, so we have to increase the count and we have to find out the minimum. So math dot min, right, a min from this one, or 1 plus, again now it's a DFS again, to balance list comma current index +1. Now I am incrementing the current index +1. right? Till now here it is, but it's a DFS. Backtracking will happen because I told you, right? What if currently it 70 200 payment can happen, but 70 40 can also happen, right? So I have to try all the combinations. So I have to set my balance again, reset balance lit dot set transaction index to the old value. What was the old value? Next 12. This was the old value. And one thing is, if I get a perfect match is like, let's say 40, here it's somewhere 40 minus 40, and if this is my current 12 and this is my next 12, right, and so this is considered as a perfect match, then I don't have to do more combinations. So that's where I wanted to skip. If current 12 plus next 12 is equals to 0, I don't want to check more combination because it is the again a best case scenario, and here I will just return min transaction count. That's your DFS approach. That's what I have explained it here, right? And what is the time complexity? Time complexity here, if you see that what we are doing, so let's say 3 members 0 1 2. So 0 is checking with 1, 0 is checking with 2, then 1 is checking with 2, right? So it's all possible combinations, right? So let's say how many members are there, it is checking with this, all backtracking and checking this. So that's where I am checking, let's saying that it is big O of n factorial. So please do tell in the comment what is the time complexity in your, what you are thinking, right? But I hope you got it, like how the Splitwise Simplify works, right? Cool. Thank you guys. I hope you will find this video useful, and this has been asked in the very top product based company, believe me, right? So do prepare it very well. Good luck guys. Thank you. Bye.